welcome to the deep dive. Today we're tackling something really quite strange about modern life, this kind of chemical contradiction, We love convenience, but we're also surrounded by these invisible synthetic chemicals. And they're often in places you wouldn't expect your nonstick pan, maybe the pizza box from last night, even potentially your tap water. They're hidden, they're everywhere, and maybe harmful. So our mission today is to help you understand this silent poison, as some call it. We're talking about perfluoroalkyl and polyfluoroalkyl substances, PFAS for short, or as you've probably heard them called, forever chemicals.
That's the term, yeah. And for this deep dive, we've gathered a whole lot of material, articles, research papers, our own notes, basically distilled it down. The idea is to get you, the listener, really up to speed on this critical issue. Quickly, but, thoroughly too.
Exactly. So get ready. We think it's going to be a pretty engaging conversation. Lots of surprising facts, hopefully some clear explanations. We'll try to guide you through this complex world of these, ubiquitous substances. Okay, so let's unpack this. PFAS, forever chemicals. What exactly are they? Let's start with the basics.
Right. So PFAS aren't just one thing. It's a big group, at least 4,700 different synthetic chemicals. They've been used commercially since, the 1940s. And their main job, making surfaces resist stuff, stains, water, grease. They're really good at it.
The ultimate repellents, basically.
Yeah.
But that forever tag, why that? What makes them stick around?
That's the core of it. Their sort of defining property is they just don't break down easily at all, really. Not in the environment, not in our bodies, not in animals. They have these incredibly strong carbon-fluorine bonds, almost indestructible. So they persist, they hang around, and they build up over time. That accumulation is the real worry.
And there's specific ones people might have heard of.
Yeah, definitely. The most studied are PFOA, sometimes called C8, which was key in making Teflon for decades. And PFOS, that was a main ingredient in Scotchgard water repellent for a long time.
Right, Teflon and Scotchgard. Okay, now you said ubiquitous. Just how widespread are we talking? Where are these chemicals lurking?
Well, this is where it gets kind of mind-boggling, seriously. Think about everyday things. Non-stick cookware, obviously. Fire retardants. Stain repellents on carpets and furniture. Waterproof jackets. But also pizza boxes, takeout containers, other food packaging, even some plastics, electronics. I've even seen reports mentioning some types of dental floss.
Dental floss, wow. Okay, so it's not just where they are, it's how deeply embedded they are in just living.
Exactly. They're woven into this convenience we rely on. It makes avoiding them, frankly, almost impossible day to day for most people.
So they're in all these products. Mm-hmm. What about in us? Are we actually absorbing them?
Yeah, that's the concerning part. If we look at human exposure, the CDC, the Centers for Disease Control and Prevention, they did a big study, found PFOA in the blood of 98% of Americans they tested. 98%. And it's not just blood. They found PFAS in breast milk, in umbilical cord blood too. So if you look at the bigger picture, it basically means almost everyone on the planet has some level of PFAS in their system.
98%. That's staggering, practically universal. And it's not just humans, right? It's an environmental issue too.
Oh, absolutely. Environmentally, they get around. Through the air, through water, they found them way up in the Arctic, even in polar bears, out in the open ocean. Closer to home, estimates suggest the drinking water for maybe 16 million Americans could be affected. That includes areas around 126 military bases, mainly because of firefighting foam, which was rich in PFAS. And just last year, July 2023, the U.S. Geological Survey found PFAS in about 45% of U.S. tap water samples they tested.
45% of tap water?
Yeah. And then, of course, they turn up in wildlife fish, shellfish, even in vegetables grown in contaminated soil or water.
Okay, so they're everywhere, including inside us. The unavoidable question then is, what are they doing to our health? I know it's debated, but what's the science saying?
Right, the health effects. Well, there's a growing body of evidence, and it links exposure to some PFAS with some pretty significant issues. We're talking potential developmental effects in children, certain cancers, specifically kidney and testicular cancer seem linked. Also liver damage, problems with the immune system, like maybe making vaccines less effective. Thyroid disease is another one. And then there are impacts on fertility, things like decreased sperm count, maybe even affecting penis size, lower birth weights, high cholesterol, ulcerative colitis, pregnancy-induced hypertension, too. It's quite a list.
Kidney cancer, testicular cancer, liver damage, immune issues, fertility problems. That is serious. You mentioned debates, though. Is the evidence really solidifying?
I'd say so. I mean, you have major bodies like the US EPA and the International Agency for Cancer Research, that's IARC, classifying some PFAS as possibly carcinogenic to humans. And here's something really telling. There was a big study actually funded by DuPont itself as part of a legal settlement. And that study found that PFOA was probably linked to their term to 6 specific diseases: kidney cancer, testicular cancer, thyroid disease, ulcerative colitis, high cholesterol, and pregnancy-induced hypertension.
DuPont's own study found probable links.
Yes. When the company's own research points that way, it adds, well, significant weight to the evidence, wouldn't you say?
Absolutely. It sounds like something that needs addressing urgently. But, getting industries to change course, it's often tough. It usually takes some kind of catalyst, like a whistleblower. Is there a key story here?
There really is. The story dramatized in the movie Dark Waters is spot on. It involves a lawyer, Robert Billett, who actually used to defend chemical companies, and a farmer, Wilbur Tennant, from Parkersburg, West Virginia. His cattle, about 190 of them, were dying. Turned out it was from PFOA leaking from a DuPont landfill nearby.
So Ballot switched sides, essentially, and DuPont knew about this.
It seems they knew quite a lot for a long time. Billett uncovered this massive cover-up, but it took him 15 years, a huge fight. Eventually, DuPont faced legal consequences. In 2017, they settled a batch of lawsuits, around 3,500 claims, for nearly $700 million US dollars.
700 million sounds like a lot, but...
Well, context is key, right? At the time, PFOA-related products were reportedly making DuPont about $1 billion a year in profit, so 700 million. Some called it peanuts in comparison.
So maybe not the massive deterrent one might hope for. Have things changed legally since then?
Things are definitely still moving. There's this concept of upstream liability gaining traction, holding the manufacturers responsible, even if they didn't directly pollute a specific site. It shows the power of determined legal challenges and, frankly, of whistleblowers like Ballot. And yes, there have been bigger settlements since. Just in 2023, DuPont, along with Chemours and Corteva companies spun off from DuPont, they agreed to nearly $1.2 billion to settle claims from public water systems about PFAS contamination.
1.2 billion. Okay, that's starting to sound more significant.
And 3M, another major PFAS producer, settled similar claims for a huge amount, $10.3 billion. But it's not over. There's ongoing litigation. For instance, the state of New Jersey is currently in a trial against DuPont and Chemours, so the legal battles continue.
Okay, so courts are starting to act. What about regulators, governments? Is there a consistent approach to controlling these chemicals?
Not really. It's more like a patchwork quilt, very uneven. In the U.S., for example, the federal government doesn't have broad regulations covering all 4,700 plus PFAS chemicals. The EPA has proposed a national drinking water standard only for 2 specific ones, PFOS and PFOA. It's set at 4 nanograms per liter, that's parts per trillion. It's supposed to be finalized early 2025, I believe.
4 nanograms per liter. That sounds tiny. How does that compare internationally, like, say, the UK or the EU?
It's actually way stricter than many other places. The UK's guidance from their drinking water inspector at the DWI is 100 nanograms per liter, but that's for any single PFAS. The EU standard is also 100 nanograms per liter, but that's for the sum of 20 specific PFAS chemicals combined.
Hold on. So the UK allows 100 for just one, while the EU allows 100 for 20 put together.
Exactly. It makes the UK standard look, well, potentially 20 times less protective than the EU's, depending on which PFAS are present. And compared to the UK's 100 angle for 1, the US proposed level of 4 angle is, 25 times more stringent.
That's a massive difference in approach. What about Canada?
Canada took a different route for PFOS. Specifically, they declared it toxic and banned its use and import. So the global picture is fragmented. It shows how policy often lags way behind the vice science, and it creates loopholes like contaminated goods being imported from places with weaker rules. It's like chemical whack-a-mole.
And is 4 angle even low enough? What do the real hardliners on this say?
Well, you have experts like Professor Philippe Grandjean, who used to be at Harvard. He's done a lot of work on this. He argues, based on his calculations, which he says align with the EPA's risk assessment, that really the only truly safe exposure level is 0, none.
0, wow. And even though the main culprits, PFOA and PFOS, are mostly phased out in the U.S.
Right, voluntarily since about 2006.
Yeah.
But they're still showing up, partly through imported goods. And here's the other kicker. The chemicals used to replace PFOA, like one called Gen X, well, there's much less research on them, but the early animal studies on Gen X, they're already showing potential effects on the kidneys, the liver, the immune system. So are we just swapping one problem for another? That's a huge question.
It feels like we're constantly one step behind. And you mentioned the UK standard being less strict. Is testing widespread there?
That's another major issue highlighted in some sources. In the UK, unlike the US push for national testing, there isn't systematic nationwide testing for PFAS in drinking water. So despite knowing PFAS are, quote, ubiquitous in the environment, they're kind of flying blind on the specifics of public exposure through water there. It's a big gap.
Okay, this is really a lie. It feels pretty overwhelming, honestly. So, for someone listening right now, what can you actually do? How can you limit your own exposure?
It's a fair question. And you're not totally powerless, even though it's pervasive. Exposure routes are mainly contaminated water, certain food packaging, and products with PFAS in them, so practical steps. Well, regarding cookware, maybe avoid older nonstick pans, those made before 2013. For new ones, look specifically for labels saying PFAS free. If it doesn't say, maybe assume it has them. Be wary of older waterproof gear, like stuff with Gore-Tex or pre-2000 Scotchgard. Check labels on personal care products for ingredients with PTFE or fluoro in the name, and don't hesitate to ask manufacturers directly if their products contain PFAS, because labeling isn't always clear.
What about local risks?
Right, check with your local health department, see if there are known water contamination issues in your area. Also, pay attention to any local advisories about eating being caught in nearby waters. If there's an advisory, probably best not to eat the fish.
And water filtration at home. You mentioned water is a big source. Do filters actually work for PFAS?
Yes, some do. Activated carbon filters, like the ones in pitcher filters or some fridge filters, can be pretty effective. They trap the PFAS molecules, which are relatively large. For more thorough removal, reverse osmosis systems are generally considered top tier. They can reduce PFAS levels by 90% or even more. So filtering your drinking water is definitely a concrete step.
Okay, that's helpful. What about the food packaging side, especially imported stuff?
Yeah, that's tricky. Imported packaging, particularly from parts of Asia, often still uses PFAS quite heavily for moisture and grease resistance. Think about those molded fiber containers, sometimes made from bagasse or bamboo pulp, often marketed as eco-friendly alternatives. They can sometimes be treated with PFAS. So if you're sourcing packaging or even just buying food in it, look for independent certification that it's PFAS-free. Traceability is key, like one source put it. If the supplier can't provide independent certification, assume the worst. It's a bit cynical maybe, but probably prudent.
Vigilance and transparency, basically. Okay, so let's pull together the bigger calls to action we found in the source materials. What are the key demands? First, seems like a big one. Is treating chemicals more like drugs require rigorous safety testing before they hit the market?
Absolutely. Then, demand immediate bans on the most clearly problematic uses, especially things like food packaging, cookware, everyday consumer goods where exposure is high.
Push for full transparency, too. Clear labeling, traceable supply chains so we know what's in things and where it came from.
Right, and make polluters pay. Not just token fines, but the real costs of cleanup and ongoing health monitoring for affected communities.
Support for whistleblowers and citizen science efforts seems crucial as well. They often bring these issues to light.
Definitely. And then the personal actions echo what we discussed. Maybe ditch the non-stick cookware unless you're sure it's PFAS free. Consider buying organic food when possible, as some pesticides contain PFAS precursors. Filter your tap water. Support science-based environmental health groups like ChemTrust was mentioned.
And maybe the most important thing, just talk about it. Share this information, raise awareness. Okay. So we've taken a real deep dive today into this world of forever chemicals. We've looked at what PFAS are, how incredibly widespread they are, the serious health concerns, the corporate history, the cover-ups, and the, frankly, fragmented and often lagging regulations.
And maybe a final thought to leave you with. For a long time, we've kind of allowed convenience, maybe ignorance, and certainly industry influence to normalize this level of chemical contamination in our lives and environment. But the information is out there now. We know this isn't about fear-mongering. It's based on scientific evidence about seeking truth and about taking responsibility. These chemicals might be invisible, but the evidence suggests they are impacting our biology, impacting the planet in really profound ways.
So maybe it's time to stop just asking for more proof, more evidence. We seem to have quite a lot already. Maybe it's time to start demanding real action, not just for ourselves right now, but for the generations to come. It's clearly a massive global issue, but it also comes down to a personal responsibility for each of us to stay informed and to act on that information.